activities. We will try to answer questions if you write them to us using our chat function. Sorry about that.
Use arrows here.
So if you'd like to ask questions during the presentation, please use the chat function in the GoToMeeting window that you have in the pane to the right. Okay, and we will try to answer them either on the fly or at the end of the session.
Yeah.
Okay, let's look at the software development lifecycle. We do our design and we generate our code, create our code, and the first question we should ask us before going ahead with any testing is really, does the code work? The most smart way to do that, an automated way to do that, is through static source code analysis and manual checking of the code. But I would prefer to use a tool like CodeSonar, QAC, PCLint, or similar. That will give us some check that the code is robust and testable. And of course, it must compile. When we've checked those things, it's time for us to look at the individual software units. And with the unit, we mean a function, method, a module. And this is where unit test tools come in. We use Cantata for unit testing of individual small units like functions, methods, etc. And we do integration test with Cantata for larger modules. Cantata is not a tool for system test where you can test your complete application and hardware. But it's possible to use Cantata for testing your software in your target.
Yeah, and just the earlier you can test it, the cheaper it is. You will find the bugs quicker and reducing cost when releasing the products. So it's a good way of actually do the unit tests as soon as possible to reduce the cost.
Yes, and that would approach the question of why unit testing. I guess most of the audience here will already understand why they should unit test, otherwise they wouldn't attend this webinar,
true,
perhaps.
True.
But of course, as the software gets more and more complex, it's difficult to go through all the paths in your software if you only do a system test with external input to the system. You need to make sure that the individual building blocks in your software are solid and do what they expect it to do.
Yeah, exactly.
And also a very important thing is that you like to automate your testing activities. And that's what we call regression testing, is where you can reuse your test scripts over and over again in your continuous build environment.
Yeah.
Okay, so when we test a unit with a unit testing tool, we also must have some criteria on to say when have we tested enough. Various software developers, in my opinion, have very different levels of saying, okay, I've tested enough. It could mean very different things. And the most common metrics to use to do some repeatable quality assurance of your testing is to use some kind of test coverage measure. And the basic of that is usually to measure how much code has been executed with the tests that you have generated. And these are few of the things that Cantata can help us with. And there are many different tools out there, the open source tools like CUnit, CPP Unit, Google Test, etc. What we would like to point out today is what Cantata can do differently, in particular in the area of real-time systems testing. And also, particularly if you have special requirements of functional safety or security for your application. So any tool you like to use should be easily to install and to use day to day. Cantata is designed to be used both on a host and on a target system. So you can run your tests both on your PC and in your target if you wish. To install on a PC, Windows, Linux is very simple and straightforward. To install on your target, it's a little bit more complex because you need to adapt the drivers for the test harness so that it can communicate the results, load the test, communicate the results some way. So your target needs to have some kind of communication possibility. Cantata is basically configured for Eclipse, but can be used under Microsoft Visual Studio and other environments as well. So apart from being able to run both on host and target, what does make Cantata different from other development or testing tools? Well, one thing to remember is that for every test tool, you need to have a generated test framework, test harness. And Cantata can automatically create the test harness, which is the software drivers that executes your test, control the results, and report the results. And Cantata does this test harness creation automatically for you because Cantata can parse the whole project you have and see what are the individual units, the functions, the methods, etc. in your software, and it can generate a test script framework for each unit automatically. It can propose parameters to call your unit. It can propose parameters for return values. You can check different things like timing, function call orders. You can check that global data has not been corrupted, etc. So Cantata has a full-featured check library which can be used to define your tests. And yes.
Yeah, and one thing more, it's the test harness is it's very easy to understand. It's completely written in C or C++, depending on what your tests are developed in. As you will see later on when I do the demo also. Okay, yeah.
Good point, Martin. So when we isolate our units for testing, and we do isolation of the units because we want to be able to repeat the tests over and over again, regardless if we have all software in our application available or not. So we try to isolate the units under test so that we can test the behavior of each unit individually, independent of the rest of the system. That means that if your unit has dependencies, that is, calls to other units, to other functions and methods, or uses other classes, then we need to isolate those dependencies those calls, and that's usually made through stubbing or making a dummy of the called unit. And Cantata has a feature to automatically understand what calls your software under test is doing, and it can generate what we call a stub for all the calls that are made from that software under test. And we do isolate the calls because we want to control the behavior of those calls. And we have two different methods of doing that in Cantata. One is stubs and one is wrappers. And I'll shortly go into the differences between those stubs and wrappers. Should we add anything here, Martin?
No, I don't think so. We can reuse the wrappers and do many instances of it, so you can easily control how the behavior should be for that particular wrapper. But I will show that also in my demo quite soon, so get a more hands-on feeling of it. So yeah, good.
So I would think possibly stubs are known to most of you. It's a simple way of isolating the unit you have under test, which is the source code in this picture. If that source code is calling another object, we replace that object with a stub. And that makes it possible for us to, for each individual test case, check the parameters we use when we call the stub, and we can also choose what return values the called object should use. So that's a very simple way of replacing the called objects in a controlled fashion for each test case. Wrappers is a unique feature in Cantata, and I think it works very well for things that we need to test in real time. Imagine, for example, that you have a call from your unit under test from your code to a protocol handler, and you want to check if your protocol handler generates a bit error. How do you respond to that bit error in your error handler in your source code? It's a situation which is very, very difficult to generate live with consistency. But if we use the feature of wrappers, we have the possibility to intercept the call to your protocol handler. You can, for each test case, so for this specific test case, we send a normal request to read the protocol frame. We may want to modify our parameters to the protocol handler, maybe not, but in any case we want to make sure that the protocol handler responds, but for this particular test case we want to modify the parameters to generate an error message instead of a normal response to a frame request. In this way, for this test case, I can then see how my error handler responds. So with wrappers, we have the possibility to both modify the parameters going to the object and modifying the parameters we get in return. And we don't need to replace the called object with a stub. We can still have it in our build. Or we could actually, in fact, use the wrapper to replace the called object in which case it's more or less like a stub. So what are the main differences between wrappers and stubs? Stubbing, well, you need to remove your called object from your build, which you don't need to do when you do wrappers. So that then becomes a compile time decision for stubs and runtime decision when you use wrappers, because you can use different test case with different wrappers. And also, when you do the stubbing, you need to have a return value. You need to define what for this specific test case the return value should be. When you use a wrapper, you can actually let the unit for this particular test case return exactly what it would normally do. The next thing I like to point out is the integrated code coverage feature that Cantata has, meaning that when you run your test simultaneously, you can check the test coverage and code coverage of the tests. And you generate a report based both on the results of the actual tests and the coverage value that you get, coverage metrics you get. And those coverage metrics you can define for a particular project. So you can say, okay, I must make sure that when I run test cases, at least 50% of my code is executed through those test cases. Or I can say I need 100% test coverage with my test cases. It's up to you and up to the requirements that your project has. And the type of coverage metrics that we can control against is things like entry point coverage, statement coverage, decision coverage. So we can check that all branches in your software under test has been taken. That's also a nice feature in Cantata because when you want to have very high coverage, you need to generate usually very many test cases. Of course, depending on how complex your unit is. So, and that's yet another indication that you should keep your units as simple as possible to minimize the number of test cases, because every branch you have in your unit under test requires at least another test case. But having a lot of test cases can mean that when you run the test, it takes a long time. So you could end with thousands of test cases. And you like to minimize perhaps the number of test cases you run in a regression test to minimize test time. And Cantata has a feature to optimize the number of test cases that you actually need to reach a certain test coverage level, meaning that Cantata can remove test cases which do not add to the test coverage. Very useful for some customers, some don't care.
Exactly.
Another nice feature with Cantata is the possibility to create test cases for your legacy code. Most of our customers do not start projects from scratch. They have some kind of a legacy code base that they need to use. And very rarely is it worthwhile the effort to generate test cases for your old code. It's a lot of work, and you already know that the code is basically sound and robust and does what it's supposed to do. On the other hand, you may want to understand that when you continue to work with that code base, you don't introduce any new errors in the old code base when you modify it. So with Cantata, you have the possibility to automatically generate test cases for your old code. Those test cases They're not what I would call smart test cases, because they don't test the functionality to your requirements. It only generates test cases to generate a certain level of code coverage. So basically they should never fail if you run those test cases. But if you modify your code and those test cases fail, that's an indication for you that someone has been modifying things, and then they may not be working any longer. An indication that you should take a look at those test cases that fail. So in one way you could say that what we call the autotest in Cantata, that automatically generates your test cases, is a way of cheating the test process. But it can also be useful for generating regression tests for legacy code. And the autotest parses your code, generates as many test cases as it can find to get a certain level of code coverage. So in this case, particular case here, we had 800 C functions and a total of 4,900 McCabe complexity, which means about the same number in branches in the code. And for this, Cantata autotest generated 5,000 test cases. It generated 95% code coverage through those test cases. It could be that there is dead code in this project which can never be reached. So in that case, you cannot make a test case to reach that code either. So that took about 2 hours to generate the test cases, and it took about 36 minutes to execute them. And then we had also let Cantata automate the test optimization, so we don't generate more test cases than necessary to reach the maximum code coverage. So if you have a large legacy base, this is a way for you to generate the test cases for them to be used in your regression tests in future projects. Last and not least, I'd like to mention also, for those of you that have requirements to fulfill safety standards like 61508, 26262 in automotive, etc. Cantata is certified for being used in the highest safety integrity levels, highest seals or A seals for those standards. And there is a certification kit that you can use to do your own qualification of Cantata in your project, free of charge. That also goes for those in avionics that use DO178, DO330, that there are also tool qualification kits available. So I think I leave to you, Martin.
Yeah, great. We'll try to do a more hands-on presentation of how Cantata looks and works. So let's see, just let me get it started. This is the view of the user interface for Cantata. It's Eclipse-based, so everybody of you that's been using Eclipse before, you will probably be quite familiar with the looks of it. I know some of the participants are doing a evaluation at the same time here, and so I'm going to do a simple demo and start from scratch. And if I'm talking too quick or if you're missing something, just let me know. Okay, let's start a new unit test. Well, we can either do it here by starting a C project, or you can go up with the file menu. start a new C project. We call it something. In this case, we're going to do a very simple something like this, and I will choose a MinGB GCC project, and looks good. Finish. I have my reverse string project here available. Let's see, and if we add some in, right now there's not any source files to this project, so if we add some source files, open, all this is done with Kiwi here, easy to see. And for you that when you're doing the evaluation or trying out the software, you can just go in under your installation folder, perhaps. No, finally, took some time. Go in the installation folder for Cantata, and you will see that there are example codes you can use directly that I'm going to use here also. Examples, C, and this is the reverse string. Okay, and here there are the source code that I'm going to use in this demo. I click finish. I'll added the source code over here, and as you can see, it's a very simple function. It's a function that takes a string and then puts out the reverse of the string. So it's not very complicated, very easy to use and understand. This demo is also included in the installation. Also, the help has a complete manual for how to use it. I'm going to add some features just to show you the strength of Cantata, but just so you can do this by yourself. Okay, if we try to build this, of course it will not work. As you can see down here, it's built with GCC and it doesn't have any main function, so it fails, but that's okay, I know that already. And if we now try to enable Cantata on this project, do this. There is a special menu down here that you can use and then push enable. When I do the build once more, here again, the software collects information about the SUT, the software under test, to see how it works. So if I build it once more, it will see down here in the console view. It builds with the Cantata, but it still doesn't have any main function, so it failed linking it. Okay, I can actually point out a slide for you. Just hold on, so make it easier for you to see how the build process works. Hold on, just put it up. Here it is. So in this case, this is what's going to happen when I do the demo here later on. But if you see here, this is the source code, the software under test we're going to test. And to that, we're going to generate some test scripts. I haven't done that just yet, but we will soon do it. And with the test script, I have the Cantata library that we're going to use and the functions in it. And when we create this test script together with the units that we're going to test and have a code coverage functionality, we're going to have an instrumentation of the source code and get a copy of it to build it together with the Cantata library, other libraries, or other options that we add to it to make an executable. In this case, we're going to do an XE to run on the Windows, but it could be any other type of binary to use on your target or something like that. And of course, all of this is more or less command lines. So it's a command line tool, so you can use it in any environment you want to, and it has plugins to many of them, so you can get it easily up and running in your environment. And when it's run on the target, or in this case on my host computer, you get a result, you get a console output, and you have a different number of views you can use to see how the test went, if they were good or bad. And also you get a summary report and different type of output to report with. I will show you this later on. So we'll see how it looks. Let's get back to Cantata. There it is. Yeah. So where we're at, I've just built it with Cantata and it doesn't have no main. Okay. Let's generate a test script then. It's quite easy. You use Cantata. Have a function that's in GUI that's generate the test scripts. This is the easiest way. I have built it once with Cantata, so it knows how the function or the suit looks like, and it suggests that the function, I will have a test case per function, and we can select the coverage rule set. This is what Mikael talked about before. Here you can put up your own rule sets, or you can use some of the predefined that's together with the installation. And in this case, I'm just going to choose one of them. It doesn't really matter, just for this demo. I'll push next here. You can see that my software actually calls on two different standard functions. As you can see, it's string length on malloc, and this is the normal string length in malloc. So okay, and I can select how to control it and yeah, so on. But for now, I'm just going to leave it as it is. And the standard, when it's using the wrapper, it doesn't change anything. It just calls it as it would normally. But we will alter the functionality and the parameters to the function later on. So you will see how it works. Okay, click finish. And you get this test script manager. And here you can see it hasn't been activated to build with this, so we just activate it, or we can choose to build with Cantata, but just activate it. Here you can see a summary view of it, the rule sets, and some other things. In the next tab down here, as you can see, if you select this one, you have the test cases. You can put up a larger screen. This is the test that's generated right now. It's the test reverse string. And down here you have the data. You have a name description in it. You have the description of what you want to, what it's going to do, and so on, and the expected calls, string length, with the default instance, and malloc with the default instance. And down here you have the input, original string, and the expected return value. So just to create a more viable test, I do something like this. Put in a string, and I expect to get an output string, so I do something like this. Okay, great. I don't have to do any return value. So this is how it looks, and if you take a look in how the actual script looks like, I'll try to put these both side by side so you can see how it works. This is the graphical user interface, and this is the actual test script. And if I try to just click on it, you can see this is the original string. And if I alter this script here, you can see it's updated in both places. So yeah, it's nice and simple, not very complicated. Okay. Let's continue. That was the test script. And I can see here it's quite easy to understand how it works. It's nothing magic about it. It's very simple and straightforward. You have the test case, test reverse string, as I have a pen here, and all the things I want to happen in the test case in here. Yeah, okay, let's go back to the graphical user interface of the test script. You have the call interface control. This is where I can alter the behavior of the calls. For example, malloc, as Mika was talking about before with the canvas example, I think, to change the bits that's coming in and out. We'll show that a bit more later on. Then we can create some checks to include script warnings and data, but in this case we're not going to have any of them, so I just click them out so I don't get any warning. There's no global data in this test, so just click them out. And then we have the possibility to change some of the settings of the make file for this test script. So okay, I think we have created the first test for our unit. I just want to Let's see if we can minimize it a bit. Save it. Okay, it's not saved. Okay, I think that's about it. Just looking so I haven't forgotten anything. Oh, okay, let's run this, see how it works. Select, run as, Cantata test. We get up a new graphical user interface. You can do all of this that I'm showing without a graphical interface. It's a bit easier to show when you're doing it the first time. So select the full build, not incremental build. Here you can select what of the tests I'm going to run. In my case, I just have one yet, so it's not very complicated. Okay, run. Let's see what's happened. It's compiling, and there we have the console output, and it is completed, but it failed. Okay, let's have a look at the console output. This is just the compiling and linking. Down here it's running the actual test I've just created for my reverse string function. And in here you can see some quick overview of how it worked or did not work. As you can see here, I was just one check that's failed. And that's my reverse string. It's my test case. And then you have the other. The other is about the code coverage, if it's fulfilled as it's supposed to be done. But let's have a look at what's happened in my test case. Why did it fail? Well, if we look in the test, let's see, make this a bit larger. If you look in the test result explorer, you have a reverse string, my test case, and you can see here it's red. It's showing it wasn't okay. And if we go drill down to init, you can see that it started. It's called string length with instance default, malloc with the default, and then you can see the return value. If I click on it, you can see that the expected was the small t, but the actual was the large T. Well, I did this deliberately just to show how it looks when the test fails. We can also see that the entry point coverage and the statement coverage was 100%, as I have chosen it to be with my rule set with the DO178. Well, okay, let's fix this simple error just to correct it here instead. Let's build and run it. It should be okay. Yeah, great. Okay, just created one test. And if I want to change the rule set, I want to have a higher coverage, I can just go in and choose another level. And I'll choose another level. I just save it, rerun the tests. You will see it will have a bit more of the coverage. I have entry point, statement, decision. Okay, decision didn't went okay. It should be 100%, but I just have 75%. That wasn't good. Then you have different views of showing where the error is. One of them is the coverage viewer. Just have to select what project I'm going to use. It's this one, I think. Rev string. And if you look, I can just make it a bit larger. If you look in the coverage viewer, you can see what of the code has been run and what has been partially run and what's commented. The green one is that's been run and executed, sorry, and the yellow one has been partly executed. And if there have been something red, that hasn't been executed at all. And it's pointed out to me directly here. You can jump between the failures in the code up here, but I just have one, so it pinpoints out the failure I have. It says one of the two outcomes is executed. Okay, yeah. That if I look in the code, it's quite easy to understand. I haven't done any test with a null case. So if I try to create just another test case, it's very simple. You just mark the first one, copy, then I have a duplicate of the first one, and I want to test the null case, like that. I expect it to be null, return, save it, and run it. So now I created 2 test cases for my software under test. Yeah, and now I just created the one that's missing to get 100% of decision coverage. Yeah, great. That was nice and easy. I'm getting in some chats. I'm trying to look at it at the same time. I can perhaps answer it later on. I'm having trouble to read. I can continue.
Well, the question is, how do you add a new function and test case in a test-first approach? That is, by adding test case before the function is fully implemented.
Good question. You mean more like a test-driven development? Well, the test generator that is in here, that's if you're going to use the automatic generation of tests, then you have to have your source code available to do the tests by generating it, or else you have to do it manually. You have to write your test before you have the actual code. And that's the normal way of test-driven development. I hope this is some of the answer you're looking for, Daniel. Or we can continue talking about that later on. We have some question and answers later on, so we can talk about it and discuss it. Okay, let's see. I've done 2 test cases, and if we, for example, have an embedded target and we have some memory problems, and we want to test this, yeah, well, I can just show you how the great function of wrapper works. Let's do this. We just copy the first test case once more, and in this instance, expected call for the malloc, we want to have a return value from malloc that returns null, meaning it couldn't allocate any memory on the target for this test case. So let's try to add that. We do a new instance of the malloc function. Let's call it memerr or something like that. I don't have any data checks. You can select, as Mika showed before, before, after, before, replace. I can show you the wrapper functionality once more, just to show you get a good idea how it works. As you can see here, this is the SUT, the software on the test, and this is the object, in my case malloc. We have the wrapper functionality. We can alter the parameters to the called object before we actually call it, and we can also alter it after we have called it and alter the results from the called object. And this is what we're going to do now to show you how it works. And of course, as Mika said, we can also replace it. Okay, my memory, I want to do a before-after wrapper. This is my new instance of the malloc functionality, the mem error, and as default, the instance doesn't do anything to the parameter or the output of that function. It just passes it straight through. So before I don't want to do anything, but after I wanted to have it to return null. It couldn't allocate any memory. Okay, save that. Go back to my test cases. This is the last test case I added. Change the malloc functionality. You can choose also if you want to have it in a certain order, but in this case I just wanted to have it my instance of malloc. That's going to be mem error. We save it, and we build and run it to see what happened. So it's compiling, linking, starting the test, and whoops, something happened. My test stopped working, and it's not the best. it's not easy to see here directly when what's failed, but if you go drill down in it, you can easily see that each of the test cases has started and ended, but the last one has just started, hasn't ended. So this is the actual software that's run on the target, or in my case on the host, that crashes. When I created the test case where malloc returned null, it couldn't allocate any memory. Quite easy to simulate with the wrapper functionality. It's not that easy without it. Okay, if we go down and have an actual look, what went wrong. Hold on, I have it here. Try to show you. Malloc returning null, just to show what happened. I have the reverse string. We check if my input string is not null. Later on, we use the malloc function to pinpoint the address to the reverse string where it should be placed. And then later on, we use that pointer, right? It's a null pointer, and that's the reason why it crashed. So a very short, very simple way of demonstrating how to easily set up all the tests. In this case, 3 different tests. Also how to see the results of the different tests. The coverage viewer, how to see the result from the coverage. And yeah, very easy to get it up and running. And also to show the functionality of the wrapper functionality. Yeah, okay. I think that's about it. Do you have something more to add, Mikael?
Well, there are lots of other functionalities. And one thing is the reporting. How do you get the reports from your tests?
I can show you one output of it. If I just put it up, hold on, just find it. You can select the different types of reports. In this case, I have. Hold on, just put it up on my screen here. In this case, I have an HTML output of the reverse string test here to see how it worked. We can see if I can try to change it. Just delete this again. Save and run. Just show you how it's updated. Soon, perhaps. Yeah. And here you can see how it worked or did not work. And yeah. So you can choose different types of output. In this case, it's HTML, but you can also have RTF or XML. And the HTML is quite handy when you're working with Jenkins. You can have the test summary report directly shown in your Jenkins build. I think we're going to talk a little bit more about it just soon. Yeah. Something else missing, Mikael?
Well, there was a question here about integration to for defect management systems like Bugzilla or Jira as well.
Okay. I don't think there is any integration to Bugzilla or Jira. I have to check it just to be sure, but haven't had anyone that's asked for it before. But I don't know there's any integration with it.
In the new version of Cantata, there is an integration with Jenkins. So with a continuous build system like Jenkins, you can report the errors that Cantata signals, the passed and failed tests, and you can drill down into Cantata from Jenkins. Maybe I should say a few words on what's coming up next, because version 7 of Cantata is due this week. So we showed you version 6 right now. One thing with version 7 is we have introduced traceability to requirements management tools like Doors, Polarion, PTC, etc. Meaning that you can link a requirement in the requirements management system to a specific test case, test script in Cantata. So that way you have a two-way traceability, and means also that you can signal test results back to doors, for instance, from Cantata. Another thing with the version 7 is we introduce a feature to particularly for larger projects where you have a repository, so a team can report centralized all test results. So you can get an overview of your different projects and the status and progress of the test work. Another feature which relates to the question here is the ability to integrate with Jenkins, and you can see the results from the Cantata test run in Jenkins, and from here you can link back to Cantata to see, okay, there was a coverage missing, or there was a test failure, and you can see what test case failed, etc.
Yeah, and when you look in the Jenkins build and you click inside on some of the tests, you will be linked back to the team reporting server, and down in that you can drill down to a much detailed level of what's failed or what's the success. Or yeah, so it's a good integration to have a good overview. Yeah, question. Let's see, I'm going to